let us discuss allocation of frames, right? Now, what is this allocation of frames? As we know that a process P, in order to continue its execution, minimum number of frames needs to be allocated inside the RAM, right? Right now, with respect to this example, right now, with respect to this example, totally we have three processes, and for process P1, the three frames has been allocated. So I have represented as so I have represented in red color, right? So process P1 I have written in red color, and the frames that has been allocated for process P1 I have represented in red color, that is 1, 2, 3. Similarly for process P2, two frames has been allocated, 1 and then 2, and similarly for process 3, two frames has been allocated, it is 1 and then 2. Now the question is how the frames are allocated inside the RAM for each and every process. So for that there are two important allocation schemes are available. The first one is fixed allocation and the second one is priority allocation. So let us discuss fixed allocation scheme. In fixed allocation, there are two types of allocations are there. One is equal allocation and one more is proportional allocation. In equal allocations, frames are distributed equally to all the process. For example, let us assume we have 5 process and total we have 93 frames, and this 93 frames we need to distribute among these 5 process. So in order to achieve this, we are going to divide 93 divided by 5. So 93 divided by 5, we are going to get 18 point something, right? So these 18 frames are distributed equally among these 5 process, right? So after distributing 18 frames among these 5 process, 3 frames will be left over, and we call these leftover frames as free frame buffer pool, right? So what is the significance of this free frame buffer pool? For example, process P1, in order to complete its execution, we have allocated totally 18 frames. But process P1 needs additional frames in order to complete its execution. In such a case, we are going to get these additional frames from this free frame buffer pool, right? Yeah. So next we move to proportional allocation. In proportional allocation, we are going to allocate frames to the process based on the size of the process, right? So in order to achieve this, we are going to use the following formula. So Pi refers to process, that is process P1, P2, P3, P4, which is equal to Si divided by S. So Si refers to size of the process, and capital S refers to sum of the all the size of the process into M. M refers to total number of frames available inside the RAM. So for example, let us assume that totally we have 62 frames inside the RAM, and we have two process, and the size of these two processes is 10 and then 127. Now these 62 frames we need to distribute among these two process whose size is 10 and 127. So in order to distribute frames to process 1, so we need to write the size of process P1, that is 10, divided by total size of these two process, which comes 137, into the total number of frames which is present inside the RAM, into 62, which comes nearly to 4, right? That is, we'll get 4 point so, and we are rounding off to 4. So therefore totally 4 frames will be allocated to process P1, and similarly we are doing for process P2, and for process P2 we are going to allocate 57 frames, right? So this is how we are going to allocate frames using proportional allocation, right? Yeah. Now let us move to priority allocation. In priority allocation, we are going to allocate frames to the process based on the priority of the process. For example, let us assume we have these 3 process P1, P2, P3, and for process P1 totally 3 frames has been allocated, and for process P2 2 frames has been allocated, and for process P3 2 frames has been allocated. Now P1 has highest priority compared to P2, and P2 has highest priority compared to P3. Now let us assume that CPU is executing process P1, right? So CPU, in order to execute process P1, totally 3 frames has been allocated inside the RAM. But CPU, in order to continue the execution of process P1, it needs one more additional frame, right? So where this additional frame we can get, so this additional frame we can get from lower priority process. Now among P1, P2, P3, P3 is the lowest priority process. So now this lowest priority process totally 2 frames has been allocated. So now, so one of the frame that has been allocated for process P3 will be assigned to process P1, right? So that's what priority allocation says. So after allocating one additional frame to process P1 from process P3, and process P1 is requesting for one more additional frame. In such a case, one more additional frame will be removed from process P3 and will be given to process P1, right? So like that it goes on. So right now all the frames that has been allocated to process P3 has been assigned to process P1. Now let us assume that process P1 is requesting for some more additional frames. In such a case, some of the frames that has been allocated to process P2 will be assigned to process P1, right? So in priority allocation, frames are allocated dynamically to the process, right? But in the case of fixed allocation, the frames are allocated statically to the process, right? Yeah. I hope you understood this frame allocation techniques. Thanks for watching. Thank you.